A bear walks south for 1 kilometer. Then it walks west for 1 kilometer. Then it walks north for 1 kilometer and ends up at the same point from which it started. What color was the bear? The bear was white because it was a polar bear, the only place on Earth where a bear can go south, west, and north equal distances and end up where it started is the North Pole. When the bear is heading west, it is just going in a circle around the North Pole. We have a similar problem when measuring distances based on coordinates for the Carolina Bays. These flat maps are similar to trapezoids, and the distances vary depending on the latitude. The distance from the North Pole to the equator is 10 million meters, and this is 90 degrees of a circle. 1 degree of latitude corresponds to 111,111 meters. The latitude lines are evenly spaced from north to south. The lines for longitude pass through the north and south poles, and they divide the Earth into wedge shapes like the sections of an orange. The distance between longitude lines is 111,111 meters at the equator, but it decreases in proportion to the cosine of the latitude. The calculation for meters has to take this into consideration. The conversion of geographical coordinates to meters in this Python program assumes that the Earth is a sphere. This implementation introduces a latitude error of about 9 meters per degree and a longitude error of 1 to 10 meters depending on latitude. The Earth is an oblate spheroid that bulges at the equator and flattens at the poles. The World Geodetic System, WGS, used in cartography and GPS, makes it possible to calculate distances between 2 points in the coordinate system of the Earth. The distance represented by 1 degree of latitude varies slightly with latitude, and 1 degree of longitude varies strongly with latitude. For the small distances involving Carolina Bays with a length of less than 4 kilometers, the overall expected error is less than the error in selecting a point along the perimeter of a bay, which depends on the resolution of the LiDAR image and the mechanism of selecting the point with Google Earth. The World Geodetic System ellipsoidal formula can reduce the conversion error from several meters to centimeter level for small spans. This Python code provides the conversion from degrees to meters at a given latitude. These calculations make it possible to find the distances between the points plotted along the perimeter of a Carolina Bay and fit the points with an ellipse by the least squares method. The goodness of fit or fitting error can be calculated from the distances of the points to the elliptical curve. Now you know how the bear problem is related to the Carolina Bays and the trapezoids. Thank you for joining me in the study of the Carolina Bays. Ask your geology professors to discuss the Carolina Bays because they are the most prevalent geological structures in the Atlantic coastal plain. There's a link to the LiDAR visualization tool by Michael Davias in the description of the video. My book about the neglected Carolina Bays is available at Amazon. Subscribe to my YouTube channel to be notified of future videos about the Carolina Bays and other scientific topics.